Just wanted to do two more examples to help make it clear exactly how this process is working. The first one here is back to the original kind of question that we looked at. Here I've got a denominator with a square root of 11 in it, and I'm trying to get rid of that. And we know that if I were to multiply by the square root of 11, that's going to end up with a rational number on the bottom. I can't just multiply the bottom by square root of 11. I have to multiply the fraction by square root of 11 divided by square root of 11, because that is equal to 1. Multiply along the top, multiply along the bottom, and I'm going to get 5 times the square root of 7 times the square root of 11. Square root of 11 times square root of 11 is, of course, going to be 11. And tidying up here, these aren't going to factorise at all because they're both prime numbers. So we really should write it with just the one square root sign, square root of 77, which I get by 7 times 11, divided by 11. And this is the best that we can do. Even though the square root has quite a large number in it now, there is only one of them, and the bottom of the fraction is rationalised. So that's what we want. Example number 2 is again an example where I've got a binomial expression on the bottom, and we know that to rationalise a binomial expression we can multiply by its conjugate, and its conjugate in this case is the same expression with a minus sign instead of a plus sign. And of course we can't just do that, we have to multiply by the square root of 3 minus square root of 5 divided by the square root of 3 minus the square root of 5, because that whole expression is equal to 1. Put our brackets in to make sure we do this properly. Okay, brackets around each binomial. Okay, and I'm not going to cheat and go straight to the answer this time, we'll do it in full. Negative 2 times the square root of 3 is negative 2 root 3. Negative 2 times negative root 5. Negative times a negative is a positive 2 root 5. Divided by, alright, let's do this expansion. Square root of 3 times square root of 3 is going to be 3. Square root of 3 times square root of, negative square root of 5 is going to be positive times a negative is a negative. Root 3 times root 5 is root 15. Inside terms, positive and a positive, so the result's going to be positive. 5 times 3 is square root of 15. Square root of 5, positive square root of 5 times negative square root of 5. Positive times a negative is a negative. 5 times 5 is 25. Square root of 25, of course, is just 5. And on the top, there's not really going to be any simplification here. On the bottom, though, minus square root of 15 and plus square root of 15 are going to cancel out. 3 take away negative 5 is negative 2. And I do have a rational denominator here, but I can actually tidy up a little bit. Everything has a 2 in it. Okay. So what I can do is cancel that top and bottom and end up with negative square root of 3 plus the square root of 5 divided by negative 1. Now, this is a bit weird dividing by negative 1. That's just the same as multiplying by negative 1. If you take a number, for example 3 divided by negative 1, we know the rules for division are the same as with multiplication in terms of the signs. Positive divided by a negative is a negative. Whoop. And 3 divided by 1 is just 3, so that would be negative 3. So dividing by negative 1 is the same as multiplying by negative 1. And the best way of dealing with that and getting rid of this horrible 1 that's sitting on the bottom is just to swap the signs on the top. So make this into a positive square root of 3, make this one into a negative square root of 5. And this is the rationalised form of what we started with.